In the last few lessons, we've been learning how to solve systems of linear equations. For example, they would give you an equation that looks something like this, and then we learned how to solve them. Now, the three ways that we learned how to solve them would have been with graphing, elimination, and substitution. So right now we are pretty good at being able to do that. Now we're gonna have word problems. So they're gonna give us questions like this, where they give us this whole long story, and what we are actually just gonna try and do is take the story that they've given us and try turn it into two of these equations, and then we're gonna use either elimination or substitution. It wouldn't really, you could use graphing if you want, but it's not really something that we normally do. So we would either use elimination or substitution, whatever you feel comfortable with, to try solve it. So you know how to solve these, but the trick or the thing that I'm going to try teach you in this lesson is how to take a story and then turn that into two of these equations. So we're going to use the story to try and make two equations. Once we have that, then we can easily go and solve. So here's our first one. Now, sometimes they use some really weird names in these questions, like Julio and Deshaun. That's quite interesting. Are selling cheesecakes for a school fundraiser. Okay, whoop-de-doo. So they're selling cheesecakes. Customers can buy pecan cheesecakes and chocolate cheesecakes. Okay, so let's just write that down. They are pecan and they are chocolate. That's usually, the thing to look out for is that they're usually going to give two different things. So that's usually like your X and your Y. But let's not do that right now. Maybe the question changes, but that's usually what happens. We look for two different things. Just like in these equations, there's usually an X and a Y. Okay, so let's see. Julio sold 12 pecan cheesecakes. So let's just write that down. Julio can do 12 pecan and 10 chocolate. 10 chocolate. That looks like a 16. Whoa, even worse. Okay, and let's see. And the total was $332. Fantastic. Then there's Deshaun, who sold, interesting name, Deshaun, 3 pecan and 7 chocolate. And that was for $173. Okay, find the cost each. That sounds a bit weird. What they're asking for is find the price of one pecan and 1 chocolate. So they just want to know, what do these things cost? So before we even get started with the question, let's say you have a little shop and you're selling red marbles. I know it's a really random example, and then you're also selling blue marbles. Okay, and let's say the red marbles are $1 and the blue marbles are $2. Now, let's say someone buys 7 red marbles. This is just an example, right? And then they buy 3 blue marbles. How would you work out the total cost that they spent? Well, that would be really, really easy, right? You would say 7 multiplied by 1, because that's how many they bought, and each one is $1. Then you would say plus, okay, and then you would say 3 blue marbles times by $2 for each one, and that would give you the total price. Okay, so this is the format that we are going to be using in these types of questions. So we're going to have the amount multiplied by the price of the first object plus the amount multiplied by the price of the second object, and that's always going to give us the total price. That should make sense to you. So now we're going to, so this is like the general formula we're going to use in these types of questions. Okay, so let's quickly go and, actually no, let's not erase that. So let's just put that back. Pecan and chocolate. Okay, interesting story. So I'm actually from South Africa, but I've taught so many learners who do the American curriculum, and that's why I understand and I know the American curriculum. But in South Africa, we say pecan, but I've heard people in America on like YouTube, and they like, I think you guys call it, well, a lot of Americans call it pecan, and I always find it really weird. But maybe you think I sound weird when I say pecan. But yeah, so I say pecan, but then a lot of people in America are pecan, and I've always found that really weird or interesting. another random fact. So as I said, I'm from South Africa. So I always used to see the state called, how do you spell it? I think I'm going to say it. I don't want to say it right now. Like that. Now, I think you guys call it Arkansas, I think, but I just always used to call it Arkansas. And I remember going to America once, and I was on the plane with someone, and I spoke about Arkansas, and they were just laughing. They were like, it's Arkansas. Yeah, random fact, eh? Really interesting. Okay, so we're going to use this little formula. Whoopsie. We're going to use this little formula that we've just made down here now. And let's say that this will be for the pecan or the pecan. And then this would be for the chocolate. And so what we need to go do is find the amount of pecans and the price. We don't know the price. That's an unknown. And then the amount of chocolate and the price of chocolate. So for the amount of pecans, it would be 12. Okay, so that's for... Oh, and let's say we're just doing Julio for now. So Julio sold 12 of those. We don't know the price. So let's say that the price of a price for one pecan or pecan is going to be X, and then the chocolate price for one is going to be Y. So Julio sold, he bought 12 of those. Oh no, he sold them. They're selling stuff. And then we're going to say plus. Now, how many... Now we're going to move on to the cheesecakes, which he sold 10, sorry, not cheesecake, chocolate. Oh, it's a chocolate cheesecake, I see. So that's going to be 10, but we don't know the price of that, so we'll just go Y. But we know that his total price spent was 332. So that formula should make sense to you, right? So the 12 is how many, the X is the price of one, and then the 10 is how many chocolate cheesecakes, and then the Y is the price of a chocolate cheesecake. Then we move on to Deshaun. Okay, so Deshaun sold 3 pecans, so shame, only 3, Sean, you can do better. And then 7 chocolate marble cheesecakes, so that's that. And the total price that he earned was 173. There we go. We now have the 2 equations, just like we used to do back in the day where we were solving with graphing, elimination, substitution. So from this point onwards, you should be okay with how to solve for X and Y. You can either choose to use substitution, elimination. Yes, you could graph it if you want to, but it's a bit weird to do it like that. I mean, that's not the way most people do it. But look, if you have a teacher who, I don't know, maybe they're very old school and they're just all about using them straight edges, and then I guess go for it. But usually it's elimination or substitution. All right, so I just went and updated this, you must just remember that that's the price of one chocolate and the price of one pecan. Okay, so I'm going to take these 2 equations that we've just made now, and I'm going to put them underneath each other. And then you can solve this however you like, substitution or elimination. I'm going to use elimination because what I notice is that these 2, I could easily turn this one into a 12. And the way that I would do that is I would take this entire equation over here and I would multiply all of it by 4. So that's going to give us a new equation of 12x plus 28y equals to, now I definitely need my calculator right there, 692. Okay, so then I'm going to erase this equation over here. And then I'm just going to write the top one a little bit closer. It feels a bit weird when they're so far apart. Okay, and so there we have it. So now I'll call this equation number 1 and equation number 2. I'm just going to subtract them now. So I'm going to say equation number 1 minus or subtract equation number 2. So this part would cancel. Then you're going to end up with 10 minus 28, which is minus 18y. And then 332 minus or subtract 692, and that will give us negative 360. Then I'm going to divide both sides by negative 18 in order to get the y by itself, and so y is 20. So what that means is that the price of one pecan cheesecake is $20. Okay, now to get x, you can just take this y of 20 and you can plug it back wherever you like. You could substitute it there, you could substitute it there, you could even substitute it into the new equation that you've just made. It does not matter at all. I'm going to use this one over here. Okay. So you're going to end up with 12x. Well, let me first show you exactly what I'm going to take this 20, which is a y value, and I'm going to replace it over there. And so you're going to end up with 12x plus 10 times by 20 equals to 332. And so that's going to become 12x plus 200 equals to 332. Then I'm going to take the 200 over to the other side, which gives us 132. Then we're going to divide both sides by 12. And we would find out that x is equal to $11. Okay, so now we answer their question. So their question was, what is the price of a pecan cheesecake and what is the price of a chocolate cheesecake? So for a pecan, or a pecan, pecan cheesecake is, that one was X. So that one was $11. And then the chocolate cheesecake, sounds good, chocolate cheesecake, oh, that's definitely how you spell cheesecake, dude. Cheesecake. That one was $20. There we go. Let's do some more examples. So we've got another 4 examples, including this one. So I tried to choose questions that are a little bit different. So the first one was people buying something. The next one is now people are going to be buying tickets. And then we're going to do 3 others after this. But as soon as you start feeling comfortable about these types of questions, because they're all fairly similar, then you can move on to the next lesson. But if you want to just stick around and go through all these examples with me, then that is also perfect. So let's have a look. The school that Sarawang goes to is selling tickets to a dancing competition. Okay, so remember, we're always looking to make our equations have x's and y's. So we're going to look for the 2 things. There's always 2 things. On the first day, here's the 2 things. You get senior tickets and you get child tickets. So those are the 2 different things, okay? Back in this question, Julio and Deshaun, they are not the 2 different things. The different things must have numbers. You can't say that there's 7 Julios or 10 Deshauns. Those are just people. But we're looking for numbers. So we're looking for like 1 senior ticket, 2 child tickets, things like that. Okay. So on the first day, a ticket sales, the school sold 1 senior ticket, okay, and 2 child tickets, and they made a total of $15. On the second day, they made a total of 120 because they sold 12 senior tickets and 12 child tickets. Wow, there's a lot of people at this school. That was sarcasm, by the way. Find the price of a senior ticket and the price of a child ticket. Okay, so let's say that the price of a senior ticket, I'm going to call that X, but you could definitely do it the other way. You could call the child ticket X and you could call the senior ticket Y. It all works out at the end. And then the price of a child ticket is going to be Y. Now forget about the numbers. Let's say that you have a school, okay? And at your school, let's say that this is just an example now. Let's say for adults, I'm going to give it a different name so you don't get confused. Let's say adults have to pay $5 per ticket, okay? And let's say that teenagers, let's say that they pay $3 per ticket. Now, let's say there were 7 adults and 10 teenagers. Then how would you find the total amount of money? Well, you would say 7 multiplied by 5, because there were 7 adults and each adult pays $5. Then you would say plus 10 teenagers, and each teenager pays 3, and that would give you the total. So that's exactly what we're going to do here. So our general formula is going to be number of, you see in the previous question it was amount. Okay, yeah, we can do amount again. So this time it'll be amount of like adults or whatever, and then how much does each ticket cost, and then this one would also be amount and then price. You see, so it follows the same generic formula, right? Pretty easy if you just think about logically like how it would work in real life. Then you apply that logic to this question, And then anything that is an unknown, something that you don't know, you just call it x and y. And then we get the two equations, and then we solve for x and y. How amazing is it? That's maths. That's the power of maths. Now, some of you heard me say that, and you're like, oh, Kevin, that is so lame. I don't care about maths. I just want to be done. I get you. I hear you. So, like, I know that you're really not interested in, like, going to a show one day and then, like, doing, like, a calculation of, like, how many adults there were and how many children there were in order to raise that amount of money. Like, no one really cares, right? I mean, look, if you do care, then that's awesome. Like, I care. I think this stuff's pretty cool. Okay, so the way that, like in the previous question, the way that we made two equations is we looked at Julio and Deshaun, okay? So those were how we found two different equations. For this one, we're going to use day 1. That's where we'll get our first equation. And then day 2, that's where we'll get our second equation. So on day 1, which I said on the first day, they sold 1 senior ticket, okay? So that's going to be... the amount of tickets was 1, but we don't know how much each senior ticket costs, so we're going to multiply that by x. Okay? Then we're going to say plus. Then we sold 2 children tickets. Geez, that must have been a really oh no, they didn't have a show that day. But yeah, imagine they had a show with 1 senior and 2 children. That's quite weird. Like a mom and her 2 daughters. Okay. So, 2, and then we're going to multiply that with, we don't know how much the children tickets are, but we know that the total amount of money that they made that day was $15. Okay, then on day 2, they sold 12 senior tickets, so that would be 12 times x, because I'm using the amount multiplied by the price, plus, how many children? Oh, also 12 children, 12 seniors and 12 kids. Okay, so 12 times y, and the total that they made that day was 120. There we go. We have our 2 equations now, and so now we just need to put them together and then solve them by either using graphing, elimination, substitution. As I said, graphing, a little bit weird to do it that way, but that definitely does work. Okay, so I'm just going to neaten up all these equations quickly so they look a bit more user-friendly. So 1 times x is just x, 2 times y is just 2y, and then 12 times x is 12x, 12 times y is 12y, and then 120. There we go. Now, in the previous question, we used elimination. Now, I could definitely use elimination right now, but I don't feel like doing that. I want to switch it up a bit, so I'm going to use substitution this time. So this is equation 1, this is equation 2. The reason I think substitution would work really nicely is that this x is by itself. So if you can remember the lesson where we watched substitution, then what we do is we need to get this by itself, okay? So the way that you do that is you take the 2y to the other side, and that's your new equation, which we now call number 3. Okay, and so what we're going to do now is we're going to take that equation, which is number 3, and we're going to substitute that into equation number 2. So what I'm going to do is I'm going to take this x now, which is 15 minus 2y, and we're going to plug that into equation number 2, which is the one that we haven't used. Okay? So that's going to give us, I'm going to write over here, so that's going to give us 12, and then in brackets, you're going to replace, you see the x and the x, but we're going to replace it with this part here. So that's going to be 15, take away 2y, plus 12y equals to 120, and then we're just going to multiply in, so that's 180, take away 24y, add 12y, equals to 120, and then you just need to solve however you want. So I'm going to take this 120 over to the other side, like that, and then I'm going to take the 24y over, so it'll become positive, the 12y will be negative, so we now end up with 60 is equal to 12y, divide both sides by 12, so y would be 60 divided by 12, which is 5. Okay, so we have y. Now to get x, you could go plug this y value into there, or what I like to do is I put it straight into equation number 3. The reason is that x is already by itself. So if I just plug in the y value there, then I instantly work out x. So I'm going to go 15 minus 2 times 5, which is going to be 15 take away 10, and so x is 5. So x is 5. And y is 5. So now we need to try solve it, answer their question. So it said find the price of a senior ticket. So the senior ticket is going to be x, which is $5. And then the child ticket is going to be Y, which is also $5. So here's our next one. Anjali and Natalie each improved their yards by planting daylilies and ivy. So there's the two things, daylilies and ivy. They bought their supplies from the same store. Anjali spent 106 on 12 daylilies and 7 pots of ivy. So I think you guys are starting to get this now. And then Natalie spent 119 on blah, 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 blah. So those are the two ways we're going to get an equation. We're going to have an equation for Anjali, and we're going to have an equation for Natalie. Now, what we could do is we could say that X is going to be the cost of daylilies, and then Y is going to be the cost of ivy. Okay, and so for Anjali, now if you've watched the previous two examples, you would know how the equations work. So I'm not going to go show you the whole cost and amount and all of that stuff. But we know that Anjali spent 106 on 12 daylilies. So we'll say 12 times X, which is the price of the daylilies, plus 7 times Y. And I'm just going to write this as 12x. And then her total amount, or his total amount, I don't know, is 106. Okay. And then for Natalie did 3 daylilies, that's 3 x's, plus 11 ivy, so that's 11y. And the total cost there was 119. So there's the two equations that we now have. So I'm just going to write them neatly below each other, like this. And so at this point, you can now decide whether you'd like to graph, substitution, or elimination. For this one, I'm going to go with elimination because I can get these to both become a 12. And I would do that by multiplying this entire equation. I could multiply that by 4. So that's going to become 12x plus 44y, and then 119 multiplied by 4 is 476. Okay, so there's what we've done there. I'm then going to erase this one, and then I'm just going to write this other one just above it, so it's a bit easier to work with. And so there we go. So we'll call this equation number 1, equation number 2. Now, we're definitely going to need to subtract them so that these two would cancel out. If you added them, then these two won't cancel. So I'm going to take equation 2, and I'm going to subtract it. Well, I'm going to say equation 2 minus equation 1. So that's going to cancel out the x's, and then you're going to end up with 44 minus 7, which is 37 y's. And then we're going to say 476 minus 106, which is going to be 370. I'm then going to divide both sides by 37, and so we're going to end up with y is equal to 10. Now, to get x, you could take that y value and you plug it into either equation 1 or equation 2. It does not matter. You will get the same answer. You could even plug it into the original y over there. It doesn't matter. In fact, that's what I'll do. I'll just plug it into this one. So that's going to be 3 times x plus 11 times y, which is 10, equals to 119. And so that's going to be 3x plus 110 equals to 119. So then 3x would be equal to 9. How did I do that? I took the 110 over, where it became a negative. So it was 119 take away 110. Then I'm going to divide both sides by 3, and I should find out that x is 3. So the daylilies are x. So they have a cost of $3 each. Always make sure you answer their question. And then the ivy, those are going to be y, which was the $10 each. So we still have 2 more examples. So I know that this is a fairly long lesson, but it's got all the good examples and the typical ways that they could ask it in class. So here we go. It says that a plane travels 1,160 kilometers to Albuquerque and back. The trip there was with the wind. It took 10 hours. Okay, let's just draw something out here. So we've got a plane that starts here at position A, for example, goes to position B. Okay, it's 1,160 kilometers. So the plane goes there, and then the plane flies back. The trip there was with the wind. Okay, so going there was with the wind. That means the plane flies faster because it's flying with the wind. So the wind is pushing the plane, okay? And then the trip back was into the wind. So that makes it a bit slower because the plane flies into the wind. So it slows down a little bit. They say that the trip back was 20 hours long. That's how fast it was on the way back. We don't know how fast it was on the way there, but it says find the speed of the plane in still air and the speed of the wind. So we want to know, what is the speed of the plane? You know, like the plane, how fast can the plane fly when there's no wind? And then what is the speed of the wind? Okay, so what we'll do is, remember many sections back, we did speed and distance and time. And what we used to do back then was we used a table. Now this is similar. These are similar questions, but you'd see that there's a few unknown variables, whereas those questions that we used to do back then, they were a little bit easier. So let's say with the wind, so that's the with wind trip, and this is into the wind. And then once again, we'll have distance, speed, and time, where we should remember that distance is equal to speed multiplied by time. Time is equal to distance over speed, and speed is equal to distance over time. I'm not sure which of those we're going to have to use. So what we could do is we could say that, now they're asking for the speed of the plane in still air. So let's say speed of plane in still air. Let's call that x. And let's say the speed of the wind is y. So think about this quickly. If you have a plane that can fly at x kilometers or x miles per hour, okay, that's if there's no wind. Now visualize this with me. Now let's say that you have a plane that can fly, let's say your plane can fly 400 miles per hour. Okay, that's how fast your plane can go when there's no wind. Suddenly there is a 20 mile per hour wind. Then how fast would your plane go if it goes with the wind? Well, with the wind it would go 420 because it can go 400 by itself plus the wind of 20. That would be with the wind. If it goes against the wind, then it would be 380 because then it can go 400, but then the wind is slowing it down because the wind is blowing into it. Okay, so what I'm going to do with the wind, I'm going to say that it can fly x plus y, just like we said 400 plus 20, and then against the wind it can fly x minus y. That should make sense. They tell us that the trip back took 20 hours. So the trip back took 20 hours. So that would be the into the wind. Oh, and they told us that the wind, this one was 10. And then we know that the distance is 1,160 and then 1,160. Now you might be wondering, okay, Kevin, like, what do we do now? Like, how do we use the formulas and stuff like that? So check this out. Remember, in all of these questions, you see how there's two unknowns. Now, back in the day when we used to use those distance, speed, time tables, there was usually only one unknown. But now we have an x and we have a y. That's the difference between these ones and the ones that we used to do back then. So if you look at the previous examples that we've done, we've always managed to come up with two equations. So we're going to do the same. What we can do is I don't really want us to use these ones because they've got ugly fractions. You see that? Whereas this one looks really nice. It has no fractions. So with the with wind one, with wind, we can use distance is equal to speed multiplied by time. So we can say 1160 equals to the speed multiplied by the time, which is 10. Ha, look at that. Now we can go and get rid of those brackets. So we can go multiply the brackets out. So it becomes 10x plus 10y. Look at that. We have an equation. Now we can just go do the into the wind one. Okay, so I'm going to do that up here. So now we're going to go into the wind. That will be our next equation. And we can just go distance is equal to speed multiplied by time. So distance is equal to the speed, which is now x minus y. And that's multiplied by the time, which is 20. Then we can go ahead and simplify. And so that's 20x minus 20y. And so now we have our two equations. We've got the one over here, and we've got the other one over here. So what I'm going to quickly do is I'm just going to go write this one directly underneath. So 1160 equals to 10x plus 10y. And so now we are at the happy place where we have two equations. And so here you have the freedom to use elimination, substitution. If you want to, you can graph it. Okay? But don't worry that normally the x's and the y's are on the left. Now we just have it on the right. It doesn't matter. So what I'm going to go for here is definitely some type of elimination, because I can see that I could easily take this equation and I could multiply everything by 2, and then I could make both of these have a 20. Okay, you could also use these ones. It doesn't really matter. In fact, I'm actually going to do that. I'm going to choose these ones. So I'm going to get I'm going to multiply this entire equation by 2. So we're going to go like this. And so that's going to become 2320 equals to 20x plus 20y. And then we now have the two equations. So that's 2320 equals to 20x plus 20y. Okay, and so what I'm going to do now is, this is equation 1, this is equation 2. I'm actually going to add them. You could minus them, because then that would cancel those out. But I'm going to add them. Adding's just always so much nicer, because then these parts are going to cancel. So we're going to say 2320 plus 1160, and that's going to give us 3480. And then the 20 and the 20 will be 40. And then minus 20 plus 20, that cancels out to 0. So now we can just divide both sides by 40, and we can get x by itself as 87. Now that we have x as 87, we just need to get y. And you can do that by plugging the x into the first equation, or into the second equation, or the first equation. It really doesn't matter. You've got the freedom to choose there. I'm just going to choose this second one here. So we're going to say 2320 equals to 20. Now x is 87, and then plus 20y. And so we end up now with 2320 equals 20 times 87 is 1740. And then we're going to say plus 20y. Now it's just a matter of solving for y. So we're going to say 2320 minus 1740, and that's going to give us 580 equals to 20y. And then we can just divide both sides by 20. And so what we'd find is that y is going to be equal to 29. So y would be 29. So let's just make sure we've answered the question. It says find the speed of the plane in still air. So that was our x. It's always important that you know what x is. So x was your speed of plane in still air. So that's going to be 47 kilometers per hour. Whoa, why did I write 47? 87, bro. So 87, y kilometers per hour. Well, we're using kilometers and hours over here. And then y will be 29 kilometers per hour. Okay, so, and that would be the speed of the wind. Here is our last example. If you've made it this far, well done. This is our last one. So here we have a boat that travels 560 kilometers upstream and downstream. So remember that the river that the boat is traveling would obviously be flowing, right? Just like the wind when the aeroplane was busy flying. So if the boat is going with the river, it goes faster. And when the boat is going into the river or against the river flow, then it goes slower, just like an aeroplane with wind. Okay, so when you're going with the wind, then you go fast. That's called downstream. So that's not with the wind, I mean with the river. And then when you go upstream, okay, so that's the upstream. Upstream. So then you go against the river, and that's when you go quite slow. Against the river, and so that's slow. This one is with the river, so that's fast. Okay, so it says here, find the speed of the boat if the water wasn't flowing. Like let's say the river wasn't flowing, then they want to know how fast would the boat be, and then they also want to know how fast is the river. So for example, let's say you have this boat. Whoa, that is not a boat, Kevin. Okay, there's your boat with a little propeller, blah blah blah. And let's say this boat, I don't know what I'm doing. Let's say this boat is going this way, and let's say that this boat can travel at 20 kilometers per hour. Then you've got this river. Now this river can flow at 10 kilometers. No, that's crazy. Let's say this river flows at 2 kilometers per hour. So if your boat is going downstream, that's when it goes with the river. Then it would go faster. It would be 20 plus 2, which would be 22. If it goes upstream, which is when it's going into the direction of the river, so it actually goes slower, then it would be 20 minus 2, and then it would go 18. Okay, so that's the basics we need to know for this question. So what we're going to do is we're going to say, let's say that the boat, if there was no river, or like if there was no upstream or downstream and the river just wasn't moving, let's say the boat can travel X by itself. So that would be like this 20. And then let's say that the river can flow at Y, which would be this part over here. Okay, so let's get started. So we're definitely going to make use of a DST table. Usually when we have distance, speed, and time, we can just make use of a table. Let's quickly write out the formulas. By now, I'm sure most of you know them, but maybe you don't, and that's also okay. There we go. So we're going to make a DST table. Wow, Kevin, you sound so cool when you say DST, bro. I want to be like you one day. I know. I'm just joking. So there's a DST, and then let's go downstream, and upstream. Okay, so the distance is definitely the same for both, whether you go upstream or downstream. If you're going to the same place, yeah. So it says that it's 560 each way. The trip downstream was 14 hours, and the trip back was 28, much slower. Then the speed downstream would be x plus y, and this trip upstream would be x minus y, just like we showed just now, right, with the 20 and the 2. Because when you're going downstream, you go faster, so you add them, and when you're going upstream, you go slower, so that's where you minus them. Okay, so what we can do now is we can make a formula for the downstream, and then we can make a formula for the upstream. So we're going to use this one. Remember, I don't like these ones in these questions because then there's fractions involved. So I wouldn't suggest that. So for the downstream, you can say that the distance is equal to the speed multiplied by time. So you could say that the 560 is equal to the speed in the brackets, x plus y, multiplied by time, which is 14. Then for the upstream, we could say 560, and then the speed would be x minus y, and then the time would be 28. So that's how we could make our two equations now. So I'm just going to go multiply both of these out. So just get rid of the brackets. So you're going to end up with 560 is equal to 14x plus 14y. Then for the other one, you're going to end up with 560 is equal to 28x minus 28y. And so there are our two equations. Okay, so I'm going to use elimination, and I'm just going to try to, I'm going to focus on this part here, and I'm going to try get this to become a 28. So the way that we would do that is we would take this entire equation, and we would multiply it by 2. Okay, and so if you multiply 560 by 2, you're going to end up with 1120 equals to 28x plus 28y. Okay, and then I'm going to erase this one because now we've modified it. And now what I'm going to do is call this equation number 1, equation number 2, and I'm just going to add them together. So we're going to add this part together, which would give us 1680. Okay, and then this part would give us 56. And then this part would cancel. Minus 28 plus 28 cancels. And so if I divide both sides by 56, then I end up with x equals to, that's meant to be a 56 over there, my bad. And so x would be 30. Okay, now to get y, I just take that x value and I plug it into there, or even the original one before we multiplied. It doesn't really matter. So I'm going to just plug it into this top one over here. So we can end up with 560 is equal to 28, x is 30, minus 28y. Then I'm going to take the 28y to the left, and I'm going to bring the 560 over to the right. And so we end up with 28y equals to 280. And so if you had to get y by itself, I'm just going to erase all of this. I need more space. So we're going to divide by 28, and we're going to end up with y is equal to 10. So there we have it. Now we must make sure we answer their question. It says find the speed of the boat. Okay, so the boat, which was x, would be 30 kilometers per hour. Why not miles per hour? Well, we're using kilometers and hours. And then the river, that's y, that will be 10 kilometers per hour.